Welcome to another KotlinBytes video. In this video, I will explain the basics of using binary and bitwise operators within Kotlin. Binary numbers are created from simple zeros and ones. They are the basis for a running program that a computer executes. Therefore, bitwise operators can manipulate binary values on a hardware level, delivering speedy and efficient results. Okay, let's start with how to represent binary within Kotlin. A binary literal in Kotlin is denoted with a 0 and a b. Everything following has to either be a 0 or a 1. As you can see, a 0b1 is simply 1, and we can see that is represented in decimal and hexadecimal as well. If we add zeros in front of the 1, it does not change the answer, it's still 1. If we add another 1 to it, you can see it's increased to 3. A byte is represented with 8 bits. So we can represent a byte by typing out 8 bits here. And just like with other numbers in Kotlin, you can add an underscore to add separations within your numbers. So we'll do that here. We'll group our binary number in groups of 4. I find this to be very useful. And as you can see, when we output this result, our binary as bin helper function also spits out the result with a space in between. This will be useful in our later examples. By the way, all the source code for this is on GitHub. The link is in the description. Our first bitwise operator is going to be the AND operator. The AND operator compares the bits one by one, and the result will be a 1 if both bits are 1, and if any of the bits are 0, the resulting bit will also be 0. So if we run this, we'll see what I mean. You can see that 1010 and 0010 results to 0010 because both those bits are 1, and all the other bits have at least 1 0. Okay, now we're to the OR operator. The OR operator works as following. If there's at least 1 1 in the 2 bits compared, the result is a 1. The only situation where the resulting bit would be a 0 is if both bits are 0. Therefore, the result of this should be 1100. Okay, the XOR operator is a combination of AND and OR in a strange way. So the resulting bits will only be 1 if the bits are different in the input. So for example, the first 2 bits are different, the second 2 bits are different, but the last 2 bits are the same. And so we get a result of 1100. Notice how if we add 2 1s in the back, it's still 00. But if we change one of them to a 0 so that they're different, you'll see that the ending result is a 1. Now we're on to the inverse operator. The inverse operator is going to invert the number, essentially inverting all the bits. From all zeros will become 1s and all 1s will become 0. Now, when you use this operator on an integer, it does change the sign. There are other ways to avoid changing the sign, but we won't cover that in this video. Okay, the shift left operator. It will shift all the bits to the left by the amount that you choose. So in this case, we're shifting that 1 bit to the left by 1. It's literally shifting the bits to the left within its own number. And if we shift it by 2, it shifts the bits by 2. And just to prove that, it is shifting all the bits, not just the 1 there. There you go. You can see that they're all shifted to the left. Just like the shift left, there's also a shift right. However, it does work a little bit differently. So if you're operating on a signed integer, such as int min value, I'm using this because it'll be very easy to represent my point. A signed integer has a binary number that starts with 1. And as you can see here, we have two very large binary numbers. The first one starts with a 1 because it's the minimum value, it's a negative value. And if we shift to the right, it keeps its sign and adds a 1 for every bit that we shift. So if we shift by 5, you'll see that we have 5 ones plus the bit that we originally had. There may be situations where you don't want that left bit to turn into a 1. So in this case, you can use the unsigned shift right. This ignores the sign of the binary value and will just simply move that 1 bit, or however many bits you have, to the right. Likewise, if we shift it by 2 or 3, it just simply moves over. That's it for this episode of KotlinBytes. Thanks for watching. Again, the source code is in the description. Otherwise, have a great day.